Hi everyone, welcome to this meeting. This is the meeting of the .NET working group in IETF 109. I'm János Farkas, co-chair of the working group with Lou Berger, and we also have our secretary, Ethan Grossman, in this meeting. So welcome everyone. Let's get started. This is the IETF Note 12, our rules. Please check if you are not familiar with them. Note that everything you say becomes part of our permanent record as a contribution. Just a couple of admin items. We use Mitaco as a meeting tool. Good that you are here. And the chat is also available in the Mitaco window and the Jabber. They are combined together. Feel free to join either one. The blue sheets are automatic. They are automatically generated from the Mitaco meeting. You don't have to bother with it. But please join the note-taking. So from this time, we are using the integrated note-taking, the new note-taking tool, the Codimid. Here is the link, and it is a great help for minute taking and double checking if everything is fine in the minutes. So please join us and help with minute taking. The online agenda and the slides are available at the usual place at the .NET meeting folder or page. And the usual stuff I mentioned already. So this is our agenda. Has not been changed for a while. We are actually going through a couple of working group drafts and some new contributions. I will not read this out. You will read it during the meeting. I would remind you about the IPR process. We do call for IPR at multiple stages. We follow the IETF IPR process, and in addition, call for IPR at specific stages. For example, before a working group goes for the last call. And we have made a good progress with multiple drafts since we met last time. So these are not, these will be not presented in detail. We have the three RFCs published, and we have made progress with the data plane drafts. Both the framework and the IP are really getting ready. They are at OAT 48, so being really finalized. And a couple of more from the core data plane drafts are with the RFC editor, the MPLS and the IP over MPLS as well. And we have the fifth one out of the ones we call core data plane ones, the MPLS over UDP IP. For this, we have requested the publication. So this is it at the final review stage as well. We have two more drafts for publication requested, the flow information model and the .NET security. These have been reviewed. We've got ISG review comments, and these drafts have been updated and to be scheduled for the very final review. We have a few three TSN data plane related drafts that post working group last call. So these ones are progressing as well. Since we are discussing these on the list, there is no presentation or during this meeting. Everything is going on the list. We have two working group drafts that are not on the agenda for today. These are the MPLS and the IPOEM drafts, but we have an OEM topic for discussion, sort of more of a framework when it comes to OEM. So that's the OEM discussion for today. as you are experiencing and all of us are experiencing, we have been working remote for a while, and it may stay for a while for some time more. So we would like to keep momentum and use all the possibilities we have for that. We use the mailing list as usual. That has been used always. So please be very active in the mailing list. Consensus is determined in the mailing list. We also have virtual meetings. Interims can be scheduled as needed. We had one in October for Yang, or that kind of dedicated for the progressing the Yang work, and we can schedule interim really as needed. So please make proposals if you see the need, and of course we chairs also think of when it is useful. The next IETF has been announced, IETF110, to be online instead of Prague. So next the March IETF will be online as well. And we also have more possibilities to foster work or progress work and work together in the virtual online space. We have the WebEx, the working group WebEx, which is available for the working group members to have meetings and discussions. Just ask us if you think that would be useful. We have regular ongoing meetings of these kinds, progressing Yang, but there could be other topics like OEM, for example, that could benefit from such meetings. So that's the intro part. Any comments, questions? Okay. Let me see. Hearing none, let's go to the first presentation, which is the Yang update. Oh, I'm sorry, I see Loa in the queue. Loa, please go ahead.
Decided to be online. Is it 110 and 111?
110. I saw announcement on 110. I haven't seen anything about 111.
Ah, okay. Thank you.
You're welcome. Okay, Don, please go ahead.
Good morning. So I'm going to give an update on the DETNET Yang. As Janos mentioned, we've been meeting weekly on Mondays. Not exactly sure in what time in your time zone. It's 9 a.m. My time zone, I think. I've forgotten all the things. Anyways, here's the list of the people that typically attend the meeting. Go on to the next slide. So the status, we've been working. We've published an interim version of the draft for people to view. We've merged Yang models, and we're working on some Yang-lint data instances for various configuration scenarios. If you have a look now, you should see that in the draft, and I think those are easier to see the things, and that helps us get these point about checking the terminology and the consistency for clarity. So we're doing that, and we've got a number of models we're working through, about 6 to 8 models right now. We've put 3 in the draft. We're checking consistency against the data plane drafts, and we're updating the reference pointers. So we currently have some comments from Rashad that we're working through. Have to get the team together. So again, if you're interested in this, meetings are Monday morning, or you can look at the draft and you can give us some feedback. Next chart, please. So here's a history of the versions, and like I said, version 9 is out there, and that was just published this week. Go on. So this diagram, you've seen it before. It just represents the main pieces of the model that we've been working on, the types of configurations. So IP over MPLS is the typical one, and we've been checking out the various scenarios for the various pieces. So the configuration through the application, the service sublayer, and the forwarding sublayer is all in there. And the drafts in reds are the ones that are driving it right now, and the other ones we have some partial coverage in. Go on to the next chart, please. And part of this is we're also synchronizing with the flow model. There is a little bit of difference if you look at the flow model. We align with the flow model, but because the Yang representation is hierarchical versus the way the flow model is described, there's a little bit of difference. But we do have all these elements in the various pieces inside there. So if you take a look at this stuff, you should find these pieces inside there, and you should be able to map to the flow model. Go on to the next chart. So here's some illustration of the types of things that we're doing in terms of aligning the terminology and just going through and making some changes for consistency. And we're just in the midst of doing that. So just cleaning up the model as well as checking out the Yang lint, that it makes sense as a readable configuration. Go on to the next chart. And just to give you an idea of the different configurations we do, so we have configuration for the egress edge node starting on the right-hand side. We have configuration for the relay node and the transit node. So, and we now support in the model, we support aggregation at all these levels. So for a while we had aggregation in some areas, but not everywhere. We think we've got all the aggregation in there. So if you're interested in how aggregation is expressed, it'd be a good time to look at it. Go on to the next chart. So this is just showing, again, some more detail about how aggregation is done at the various pieces. In some of our other presentations that we do, we have some more detail. And then how the disaggregation is going as well. Okay, go on to the next one, next one. So these are just the various scenarios in there. That's probably extra detail. All right, so the plan is get any more comments, review the model, check for flow consistency and general cleanup. And we're adding references and including the Yang lint sample configuration. Trying to get to a last call. I think that's the last one.
Thank you very much, Don. So Lou and Chesong are in the queue. So Lou, please go ahead.
Sure, thank you. Don, you mentioned you're trying to do some consistency with terminology and naming, and you showed an example where it looks like you've introduced a new term. Can you talk a little bit about what strategy you all are following, and if you think you need new terms, what are they?
Well, hopefully we didn't introduce a new term, but we haven't rationalized that. So that's because we just been changing the model terminology. It's still a bit of a work in progress, but we're trying to review that to make sure that we're consistent with the data plane drafts and the flow model.
Yeah, it's the I think it was on the fourth slide. you talked about upper, and it shows in a number of slides.
The upper and lower.
Maybe next one after that.
Yeah.
And keep going. Yeah, there you go.
Yeah. So the upper. So that's been introduced right now to show that when we're aggregating at the various layers in terms of the model. I don't know whether that will stick. It's just new terminology that's happened in this version, and we've just been, working our way through it. So that really hasn't gone through a comment review. So we will be discussing that, as we go along.
I would suggest any major new terminology. It would be good to discuss that on the list. All right, thank you.
Okay, thank you. Chasson, please go ahead.
Hi, this is Chasson speaking. Thank you, Don, for your presentation and some brief response to Lou's comment. Actually, we are not going to introduce new terminologies in this young model, and all the terminologies will align with the previous data plan documents. And here, we doing the naming updates just to make the young model more easy to understand. For example, the aggregation, what kind of aggregation and how to do that. So there is no new terminology, but just to updating some naming and do the clarification. And another comment is some supplement about our work. Actually, maybe you all noticed that Don go over the aggregation part so quickly because we have do the presentation in the materialism. So if people are interested in this part, please go to the materialism of the materialism, and there we have a lot of details about what we have done, and also comments that are helpful. Thank you.
Thank you very much. And I don't see anybody else in the queue. So thank you really for the team for progressing this work. Now this is, I guess, our major next step to complete. So everybody is really welcome to contribute and review and help finalizing. So let's move to the next presentation, which is about the bounded latency. I'm not sure who will present.
Hello.
Hi.
This is Jiayi Zhang from Huawei. I'm honored to make the presentation.
Please go ahead and let me know when I switch slide.
Okay, thank you. Hello, everyone. And this is about some update of the bounded latency draft. And please, next slide. Just a quick reminder. This draft is about upper bound of the end-to-end latency of a network. We do not consider the low average latency or some simulation or instance of a latency. Based on the upper bound, we can get the exactly how many buffers are required in order to achieve the zero congestion loss. And in this draft, we also do not consider the feedbacks for some congestion control. And we mainly focus on giving the mathematical sound assurance to give based on some specific scheduling that how to get the theoretical upper bound of the latency. So next slide. A quick reminder of the current state is this is informational track, and the content includes the timing model for flow creation and relay node model. And in order to get the end-to-end delay bound, we separate into two parts. First is the non-queuing delay bound, and second is for the queuing delay. And in the queuing delay, we may separate it into many scheduling. There are examples given in the section 6. And based on the end-to-end delay upper bound in the section 5, we can calculate the backlog bound in order to achieve the zero congestion loss. And In the section 6, we give many examples. You can see the detail in the draft. So go on. And here's the major changes from the version number 1 to the current version number 2. Our idea is to reduce some details that referring to IEEE 802.1 TSN schedulings. We do not want to detail the schedulings in this draft, but we want to make the draft currently more concise and conformant to the DETNET work group. And the main changes is in the section 5, we update the formula for backlog. And in the section 6, we simplify the time-aware shaping and also simplify the interserve section to make it more clear. And one major change is that we modify a lot in the cyclic queuing in the forwarding. Previous version is for the 3-buffer scheme. We have many details for the scheme. And in this version, we focus on the 2-buffer scheme. It is more consolidated, and we also give the delay upper bound in the draft. Details also can be referred to the IEEE TSN. So we look forward for your comments in this main changes here. Please go on. And just quick information for the 2-buffer CQF, the delay analyzed for the end-to-end delay upper bound. And the CQF is, we have 2 buffer, buffer A and buffer B. Consider that they are switched at every cycle. The cycle length is TC. When the buffer A receives message and the buffer B transmits, and then it switches at another TC, while the buffer A transmits and buffer B receives. So a package will stay in this one node. At least it enters the buffer in one cycle and leaves on the next cycle. So we can calculate the one hop delay is from 0 to 2 TC, and also the end-to-end delay bound is from the k minus 2 TC, and with the maximum end-to-end delay is k TC. Also, we can have the delay jitter is no more than 2 TC. So this is a quick information for the 2-buffer CQF delay bound. And let's go on. And for the final steps, and I'm sorry to say the final, but we are doing the consistency check with the other workgroup drafts. And from the author's side, we think the content of the draft is stable currently, and we welcome any input from the workgroup. So do you think it is possible for the status to ask for the workgroup last call? So that is the current state of this draft. Thank you.
Thank you. Thank you. Thank you for the presentation. And I think we should discuss the going for working group last call. For me, it looks very good that there is progress. What is the view from the working group? Is there any objection to go to working group last call? Shesong, please go ahead.
This is Shesong speaking. I have reviewed the updated document, and I think it is reasonable to clarify and simplify the contents of shipping mechanisms, because which are not defined in the IETF community. So I think it's the document is in good shape. Thank you.
Thank you for the feedback. It's always good to have feedback. Anybody else? Not hearing anybody. It sounds like a good move to go to last call. So we will synchronize on that among chairs and authors. Thank you. Let's go to the next.
Okay, thank you.
Thank you very much. Let's go to the next draft. Who will talk for the microburst?
Hello.
Hi.
Hello.
Yes, I can hear you. Good.
I'm Zhong Pengdu from China Mobile. I will present this. I will give the description of this slide. Okay. Hello everyone. This slide is about microburst decreasing in layer 3 network for those low latency traffics. Next slide, please. This slide is about the motivation. We care about the 5G barrier network. This figure is a 5G system which controls the control plan and the data plan. We can see that there is transport network on the 5G system. They are used to provide connection service for 5G data plan and the control plan. Though not in the standardization scope of 3GPP, some of the 5G requirements also motivate the evolution of the 5G barrier network. This barrier network is often IP-based. Next one, please. This slide describe the deterministic requirement in operators 5G barrier network. The URLC is one of the key aspects in 5G. It is an end-to-end requirement, so that the transport network mentioned in the last page also need to provide low latency service. However, it is very hard for the 5G barrier network to provide a deterministic service because traditional IP network are based on statistical multiplexing and can only provide BE service. They are short of the SLA guaranteed mechanisms. Next slide, please. This slide is about the related works in IEEE and IETF. IEEE, the TSN task group has completed many projects for providing deterministic service through their 802 networks. There are some characteristics about it, and IETF.NET working group also have done a lot of jobs to enable this deterministic data passes to operate over layer 2 or layer 3 segment. However, .NET now is supposed to work in campus-wide networks and private ones, and not cover the very large-scale ASP network scenario. In summary, there are some still gaps for 5G barrier network to become deterministic. Next slide, please.
Question there, is that all right? On the previous slide?
Please go ahead.
Okay.
Yeah, you say that it's .NET is targeted for campus. I'm not sure we've seen that scope. Certainly, signal administrative domain is our scope. It doesn't. A single administrative domain could be small. It could be very large. So I'm not sure what comment you're making there, and I don't think it's accurate.
It is based on my understanding, perhaps some misunderstanding here. But I think the TSN mechanism is not designed for a large-scale ISP network. Is that okay?
I'm talking about .NET, not TSN. So DETNET, TSN might have a more narrow scope, but DETNET, its scope is not based on the size of the network. It's based on distribution of control, of administrative control. We can discuss it more on the list, but I think there's a little confusion there on the DETNET part about the scope.
Okay.
Yeah,
Right,
I fully agree with Lou, actually, that our charter says word by word single administrative control or within a closed loop of administrative control. And I think an ISP network is absolutely in scope of DETNET. So there may be misunderstanding in the charter. Campus is just an example, but I think it is in scope of DETNET. But yeah,
Okay.
let's discuss on the list further or clarify this later. So
Okay.
please go on.
Thank you. But I think I will go on. This page we show some gaps for large-scale layer 3 deterministic network. Currently, we are short of common and mutual mechanism that can provide deterministic transport in 5G barrier network, and that is used to be a draft for this large-scale DETNET. They provide a potential solution based on some enhancement to CQF in TSN. We think it is a good explanation, and we think that TSN mechanisms are designed for layer 2 network originally and cannot be directly used in the large-scale layer 3 network. The main reason is about the simplicity and the scalability. The former can ensure that the mechanism is easy to deploy, and the second it can ensure that the mechanism is able to fulfill complex requirements. Next page, please. This page we show some reason why TSN mechanism cannot be directly used in large-scale layer 3 network. The first one is some TSN mechanism need a synchronization of network equipment, which is hard in large network. It is to say that it brings in some complex maintenance jobs across a large distance, but the jobs are not needed before. And the second is some TSN mechanism need a per flow state in the forwarding plane, which is unscalable. The third is that some mechanism, the TSN mechanism is a constant and foreseeable traffic characteristic, but is more compacted in a large network, which include much more flows going in and leaving randomly, and the traffic characteristics are more dynamic. Next page, please. When we are seeking the problem in current IP forwarding mechanism, we found that the main problem is that in the current IP network, a long delay in queuing or some packet losses due to bursts are accessible, but it's unaccessible in the deterministic forwarding. Even be given a high priority, a packet can experience a long congestion delay or be lost in a relatively light-loaded network because of the problem of microburst. The microburst is a special case of network congestion, which typically lasts a short period at the granularity of millisecond. In the microburst, a lot of data are received on the interface suddenly, and the tempered bandwidth requirement would be tens or hundreds of the average bandwidth requirement, or even exceed the interface bandwidth. Next page, please. This page is about the introduction of the microburst. On the left finger, we can see that if we observe the traffic utilization bandwidth on the interface at a granularity of per second, a smooth curve may be obtained. But we when we observe the traffic utilization bandwidth on the granularity of a millisecond, we can see microbursts on the interface. In most cases, the buffer on the equipment can handle the microbursts. However, in some corner cases, microbursts bring in a long delay or even packet loss. Next page, please. This page analyzes some causes of the microbursts. Firstly, IP traffic has an instinct of burstiness, no matter in micro or macro aspect. It is to say that it does not have a constant traffic model. Secondly, IP network has a flexible topology where the incoming traffic may exceed the bandwidth of the outgoing interface. For example, an interface with a large bandwidth may need to send traffic to an interface with a small bandwidth, or multiple flows from several incoming interface may need to occupy the same outgoing interface. Finally, the IP node have been designed to send traffic as quick as possible, and it not whether the downstream node's buffer can handle the traffic. For example, we show a finger here. Before the scheduling in IP network, the packets are well paced, but after scheduling, the packet will be gathered even the total traffic rate is unchanged. Next page, please. We propose a potential idea to decrease the microburst in the network. In fact, mechanisms in TSN can handle the microburst problem for deterministic traffic, but at a relative higher cost, as we analyzed before. Our draft proposed a mechanism. This mechanism, including in the PD node, do the flow shaping and color all the deterministic traffic, and in the P node, recognize the deterministic and do a per interface shaping. So it's more easier for the network equipment to upgrade. The purpose is to maintain a proper buffer depth on the P node and forward the deterministic packet orderly instead of as soon as possible as in the current IP forwarding. Our first job includes first we need a mechanism in control plan to guarantee the total bandwidth on the interface is not exceeded. Secondly, we need a convenience way to for the service to inform the network about the bandwidth they need. Thirdly, the deterministic traffic should be colored so that the P node can recognize them. Next page, please. That's all for thanks for listening and welcome for comments.
Balázs, please go ahead.
Yes, Balázs Varga speaking. Just a question for clarification. So, have you considered what is the cost of eliminating this microburst as you're proposing? So it is provided by additional delay that will cause jitter for the DETNET flows. So have you considered that effect?
I think in our understanding that TSN mechanism perhaps can handle the microburst problem, but at a relative higher cost. And our purpose is to increase the microburst at a lower cost. We done some simple idea to achieve the low latency traffic transport. Is it okay?
I think we need some offline discussion on the details. Okay.
Okay. Thank you.
We are actually running a little late. So thank you very much for this. There's a lot more in this presentation than that's actually in the draft. So we look forward to the next version, which may have some more details in it. Also, I think you might be looking for an informational document than a standards track. A standards track is all about defining either protocol extensions or specific mechanisms. So I think you might be headed more towards informational, which is just fine. But we'll see as you get more content into the draft.
Okay, thank you. Yes, I'm sorry, Edward. I see you in.
Yeah, if you don't mind taking it to the list, just because we are running a little late.
Thank you, thank you. So OAM is the next.
Okay,
Please,
I'm ready.
Please go ahead.
Okay. Okay. Hello. I'm Greg Mirsky, and I'm presenting this work on behalf of the group of the authors. We had a discussion of their document that was presented in a reliable wireless raw working group, and agreed that we'll work on new document to be discussed and worked in DETNET that will be a common OEM features that are common for DETNET and the RAW. And the document that will be continued working in the RAW working group will concentrate on this technological specifics of wireless and OEM in the wireless reliable network. Next slide, please. So the structure of this document pretty standard, and it includes their terminology, OEM methods classified and characterized based on RFC 7799, which kind of is active, passive, and in between. We use in this first version terms like map and MIP. It's maintenance endpoint and maintenance entity intermediate point. These are not often used at IETF. I can only point probably for one technology where we use them, but they're more often used in other SDOs. So we would like you to think and comment whether we should switch to other terms like endpoint and intermediate point or transit node. And then we have sections that look at aspects of OEM for operation, administration, and maintenance. Actually, that's what the acronym OEM stands for. Next slide, please. So operation, what is objective of operation? It's to keep network up and running and have fault management and performance monitoring. Information collection, it's a passive measurement method according to 7799, and examples could be using SNMP based on the MIP, or Yang data model notifications, or gRPC. Usually it works out of band comparing to their monitored flow, or it could be in band. Definitely out of band is a more conservative approach, though out of band probably is lower guarantee of collecting the data or not losing the data. Continuity check. As you see, we differentiate between two functions on the fault management. The continuity check is usually concerned of the continuity of the path. So which, if we take an analogy for electricity, it's that, well, there is a wire that connects point A and B. And examples of continuity check, it could be, for example, ICMP echo request reply, known as a ping, or BFD protocol. Another function in fault management is a connectivity verification. And if continue using this analogy from electrical wiring, is that we have a specific wire that connects point A and B, for example, red, and we don't receive the electrons that travel on a blue. Then one important operational function is route tracing. It's ICMP echo request, known as a trace route. Fault detection localization are very important. And one very important thing that we need to stress and remember when we discuss and consider OEM, active OEM, the test packets must always be in band. Because if active OEM packets are not in band, that the fault detected or performance measured are not applicable to the flow that we monitor. Next slide, please. So the objective of administration functions are keeping track of resources and how they're used. That include the telemetry information, and telemetry information is something that is measurable, or it's a network state information. For example, buffer occupancy, queuing delay, residence time. It's very important to use metrics that are additive, that characterize the node, but then can be combined to characterize end-to-end metrics. Measuring end-to-end metrics might not be useful and sometimes may be misleading. Next. Maintenance. The objective of maintenance functions is facilitating upgrades and repairs. So again, it's important to collect telemetry information, enable network state condition evaluation, and collection methods might have impact on the network resources. Because again, as was mentioned in the second slide, that if the telemetry collection is in band, that it takes the available bandwidth from the service. And next step discussion. So we'll have the document for sections that list common OEM requirements, includes section applicability of hybrid OEM in a DETNET. And hybrid, it's methods that combine passive and active. And we always welcome comments, suggestions, contributions, and want to ask to consider a working group adoption. Thank you.
Okay, thank you very much for the presentation. We have two people in the queue. Balázs first.
Balázs Varga speaking.
And Walter, if you don't mind, we've just started a show of hands poll asking how many have read the draft.
Okay.
Yes, thank you, Lou. Thank you, Lou. Let's do the show of hands first. So please open. Did you want to say something, Lou?
I think we can do it while Balázs asks this question.
Okay, good point. So please fill in your show of hands. It's next to the chat window in Mitaco while we are discussing the questions.
Okay, so just 2 comments. I was very happy about your proposal on the terminology to use the maps and MIPS. So I am supporting to have that that terminology and discussion regarding that net OEM framework. The second comment is also related to that. That I think what I miss still a little bit from this document, which is providing a very good basis for the OEM framework, is that we have in DETNET defined 2 sublayers, the service and the forwarding sublayer. And I think it would be great to have also some thoughts about where to place these maps and MIPS regarding those DETNET sublayers. So that might be an interesting discussion, and that can provide also some input for the IP and the MPLS specific OEM document from framework perspective.
That's very interesting. Thank you.
Okay, thank you, Shesong, and we should speed up a little bit because we are over time.
Hi, thank you. Thank you, Greg, for your presentation. Very quick question, because I noticed this contents are very similar to your previous document in raw working group. What is the relationship with these two work?
Their idea is that the raw document will be concentrating on raw specific and then referencing this document for more general aspects of OEM framework. Because as we discussed and agreed that the DETNet is less technology exposed, so it's a better place to have the framework for common OEM, and then have some specifics of OEM in the wireless technology, because there are specifics, and their balance between what is in band and out of band would be different if we talk about wireless or wireline networks.
Thank you. Actually, we are in trouble with the time. Can we move the remaining questions to the list?
Okay, I will put it to the list.
Thank you. I'm sorry, Sue and David, but we are over time. And we had a good number of people who read the draft. Please, please read the draft and continue the discussion on the list.
Yes, thank you.
Thank you.
Yeah, and to both Sue and David, if you can send your comments to the list, particularly if you would object to adoption, that would be really helpful. So sorry for the short time. We only have an hour for the session.
Thank you. So let's have the next one.
Okay, thanks. Hi, this is Doug Crossen. This is a new draft that we've submitted to the working group just recently, presenting on behalf of my co-authors, Franz and Jürgen from Siemens. If you can go to the next slide, please. So the slide focuses on the control plane signaling in accordance with the control plane framework that we are referencing in the draft as well. At the moment, we are targeting to cover the distributed, centralized, and hybrid signaling scenarios that are outlined in the control plane framework, but we've focused so far on the distributed part. Yes, and I'm trying to keep my time down. What we intend to do is particularly solicit feedback. That's the whole point of presenting here. So the main focus of the work at the moment is section 2, in case you haven't read it. The main proposal for aligning layer 2 and layer 3 signaling, which I will have a slide on later on, which is the part where we are soliciting feedback, is in 2.5 for you as a navigation. And section 3 and 4 might be for future work. So the baseline, as mentioned, yeah, next slide, please. Thank you. Is that we cover the 3 cases, with distributed being the focus of the draft, the other ones for potential other contributors or from us to be filled in. Thank you. The next one, please. So the draft starts with discussing the main difference between RAP as an example for TSN and RSVP. This is done throughout section 2.4 to cover certain aspects that where there are differences between the 2 models that are applied in RAP for TSN and RSVP, assumptions on network nodes, the mapping of the latency model, how to deal with latency margins, how to deal with jitter and non-shaping nodes, but also how to map resource reservation stars. That's all discussed in 2.4. And up front, we start by asking a number of challenges in section 2.2, and the foremost, if RSVP inserv is the right starting point for the alignment, which we then come back later in 2.5. And then how to effectively address those various issues that are discussed in 2.4. And also what's the nature of the interface between RSVP and RAP in the scenario. So next slide, please. So this is the interactions that we outlined in figure 2 of the draft. This is a slightly prettier looking version of it, where we have the assumption of a bridge scenario here from an end system over a first router to another end system on the right-hand side that we left out here. It's included in figure 2. The main interface that we're discussing in the draft is obviously focused on the layer 3 control plane. And we mentioned the TSN API in section 2.6 as an example that can be used. And so the focus is on the DU API and the DL API that is shown here in the figure. The next slide, please. So what we're proposing, which is what we're seeking feedback from the working group, is the rationale or the introduction of what we call RSVP DETNET. The rationale to split the control over the resource style and the sender selection that would align RSVP to the announced model of RAP, where the resource style is actually known when propagating the announced downstream. So it aligns the model used in networks like TSN better with the signaling you would do on layer 3. That's the first part that is being discussed in the proposal for RSVP DETNET. The second part is also to introduce another resource style, the so-called coordinated shared resource, which would support a large amount of deterministic connections with a small data usage, instead of scheduling all of these connections into a shared resource. That's one of the other part that we are discussing in that proposal. The API specifications are then given as an example how this could look like in sections 2.261 and 262. This is for the DU API and the DL API that I showed in the previous figure, and the example TSN API, just for completeness, is given there. Go to the next slide, please. So the future plans is as I said, is an initial draft. This has been brought up specifically to solicit feedback on the proposed changes to the signaling in RSVP, given that there are also discussions on and work on RAP ongoing in IEEE, and in particular Jürgen and friends are very involved in the IEEE work as well. So the split of the resource control and the sender selection is the part that's being proposed, and the possible goal here could be to go for a specific specification of what we call RSVP DETNET in the draft. Second plan is also to outline and revise the DU API to make it independent of the particular model of signaling, distributed, centralized, and also add the missing version for centralized and hybrid if the material, and we find co-contributors as well. Foremost, apart from the feedback, obviously we solicit also and welcome co-authors and contributors to the discussion from the mailings. Thank you very much.
Thank you very much, Dirk, for the contribution and the presentation. As we are running out of time, I would suggest a discussion on the list. So please put your question and comments. Please read the draft and discuss it on the list. So let's move to the next and the last presentation to have some time for it.
One comment from Chaber is there's some suggestion to have an interim so that we can have more time, particularly to discuss new material. I think that's a very good idea. Maybe we'll try to schedule something. We'll discuss offline and probably try to schedule something in December. So thank you for that suggestion.
Thank you.
Okay, this is Fanyan from Huawei. This will be very quick. The draft name is the segment routing for the redundancy protection. Next, please. Yeah, actually, we have already introduced this work to DETNET for several meetings. So this is only the plan that we are going to notice the DETNET working group. Maybe next, please. Yeah, we take this service protection function and from the three DETNET techniques. So we rename it as the redundancy protection as a generalized service protection solution. So we propose a new draft to Spring Working Group and to define the segment and also the other information like the metadata and redundancy policy in this new draft. We may expect more the other extension works in the spring and the 6-month working groups. So as what we get the comments from the DETNET working group chairs. So we did this work, and we like to inform the DETNET and collect the feedback from the chairs and also the working group. Yeah, that's it.
Okay, thank you. I would like to mention that we started to coordinate with the spring chairs, like DETNET chairs and spring chairs on the topic, and it was discussed at last IETF when it was presented, IETF109, that this should happen. We started doing that, and this work really should be coordinated between the two groups. Spring is the home for the SRV6.
Yeah. Oh, okay. We'll keep this this work between the two groups, working groups.
Oh, okay. So I see you in the queue. Do you want to say something?
Sue Harris? Maybe she just left herself in queue from before.
I guess so, yes. Okay. Any further thoughts on this draft? Oh, maybe Sue wants to say something now. Please go ahead. Okay, we are over time a little bit, so we need to close the session. Thank you very much for all the contributions. And as we discussed, let's continue the discussions on the list, and we will work on an interim and then discuss how to do that, or how to progress with all these new work items. So thank you for the contributions for today, and then keep in touch in this remote online way of working as we discussed. Thank you.